Hello and welcome back to the Coking.com channel. I am here at ValvTechnologies and we are on site at their materials coatings laboratory. I'm here with Todd McLemore. He's going to be teaching us a little bit about coatings technology as it pertains to their products. So Todd, welcome to the channel. Could you give a little introduction to yourself to our audience?
Absolutely. Hello, everyone. My name's Todd McLemore. I'm the Vice President of Product Development and Marketing.
Thank you. And we have here, this is a sample of your coatings technology, and you said that this is an HVOF coated application, typically for the delayed coking industry. But can you give us just kind of a quick primer on the various different coatings that are available to us?
Absolutely. So within thermal coatings technology, there are several different applications that are available in the industry. The two that we apply here at ValvTechnologies are HVOF, which stands for high velocity oxygen fuel, and plasma spray. The two primary differences in HVOF and plasma are temperature, because HVOF does not spray and heat the powdered materials up as high as plasma does. The other difference is the type of materials that you can use, the types of metal that can be used. You're limited in certain softer, lower melting point metals with plasma. They don't adhere as well when you apply them via a higher temperature like you would with HVOF at a lower temperature.
Okay. And so for the coking specific application, because that's what we're all about here on this channel,
Yes.
is HVOF.
Correct.
You have some sort of blend of different elements, and obviously the special recipe is double top secret, but can you tell us a little bit about the range of components that you tried to mix and match to hit the hardness and the properties that you would like to see?
Sure. The two most common metals that are used or alloys that are used are tungsten carbide. That's been around for decades, used in this application, and chromium carbide. We use a blend of the two. Chromium carbide has a better corrosion resistance on its own than tungsten carbide, but tungsten carbide's significantly harder, has a higher melting point than chromium carbide, has a greater wear resistance, and obviously with a higher melting point, greater resistance to high temperatures. So we use a blend of the two. In some cases, we use chromium carbide alone and different variations of that, and we have several different types of tungsten carbide standalone coatings, but in this case, in this application with delayed coking, it's a blend of the two.
Okay, perfect. And so what do you do with this little gizmo, and explain to us what you have maybe behind it?
Sure. So this is a sample coupon, part of our QA/QC process with our coatings to make sure we have consistent application, most importantly, consistent performance for our customers with every batch of spray coatings, whether it be with HVOF or with plasma. We have several coating samples made within that batch, store those like you would any other sample lot for QA/QC. And with this sample itself, we test it in several different ways here in our material coatings lab. And what you see here on the screen is an example of a porosity image of a sample like this, and it would be looking at a cross-section where you see up here the dark area. That would be the substrate, your ball or seat.
Sure.
And the lighter area is the actual coating applied. And what you see here, the lighter the color, the greater the density, greater the porosity. These dark areas might be, they could be pores or porosity. They could be voids, depending on how at what temperature and at what rate of spray the coatings were applied. And this gives us an idea. The more dense the porosity, the greater the hardness,
Sure.
greater adhesion you get. This is an example of something that we're working on. This is not an example of our HVOF coating that we apply right now, but this helps us in our R&D process get closer and closer to a perfected and commercialized coating.
Perfect. Well, we really appreciate you sharing us with a little bit about the science, but let's bring it back to Coker specific world.
Yes.
Because that's what we're all about. Here we have a couple different balls. If you've seen from our other videos with ValvTechnologies, these props used elsewhere. But as it pertains to the coating specifically that we put on the ball here, I know that after some years of operations, despite all of our best efforts, the coatings sometimes get, worn out or damaged, right?
Yep.
So we had a bit of a discussion about if and when the coatings fail, how can they fail in a way that is acceptable and unacceptable and requires full refurbishment and whatnot. So can you just share with us a little bit about how you would evaluate the coating kind of an as-found condition?
Sure. One thing to note is when we coat our substrates, whether it be a ball or a seat, we're covering the entire sealing area, not just a sealing band. We're covering the entire surface area of the ball and the seat. Sometimes what will happen is you could get pitting from. It could occur during when you're putting the ball, when the installer is putting the ball in place at a facility. It could get a ding. It could happen from over time. You could have a pit or a scratch. Some of those are going to happen. Where you have trouble, and where our customers get into trouble with these, is when you have enough erosion in a coating surface area that it creates a leak path.
Mm-hmm.
That's what you don't want in any type of pressurized valve situation. The areas that you're most concerned about are leak paths that are going to be in the sealing area near the bore or where it meets the seat.
Yeah, so that would be here where it touches the seat, or potentially here where it's in the fully closed position. These are the spots where
correct.
It needs to be as perfect as possible.
That's correct. A lot of times what we've found is the way that the balls and seats are designed, if they aren't designed properly, and I won't tell you how.
Okay.
But if they're not designed properly and the coating isn't applied properly at these edges, it will leave a leak path kind of like a scratch would here, mm-hmm. which will allow it to delaminate. We've perfected through a tremendous amount of testing.
In this very room, I'd imagine.
Here, yes, and in our spray booths, where we make sure that doesn't happen at the edges where the coating's applied. Imagine you have a sharp corner versus a radius corner, okay? And you have less ability for that to delaminate that way.
And these are very hard coatings, so if there's an edge of it between the substrate and the coating, it just becomes a spot where it just wants to lift off.
Yep.
I can visualize that.
If you think about chromium carbide and tungsten carbide, there's only two other blends that are any harder than those two, and that's niobium and vanadium. So,
okay, those sound expensive.
They are, and not commonly used. But,
okay,
but they work.
So moving from this medium-sized ball to the slightly smaller one that you saw in the other videos, this is the ball that we're all familiar with, and this is the integral seat.
Correct.
So if you do happen to have a coating-related issue on refurbishment, you would have to do some sort of repair and refurbishment to both of these because these are lapped together.
They are mated, yes.
Yeah.
They are a pair. They come together. What you would have to do, if depending on the severity of the damage, we would grind the old coating off,
mm-hmm.
Reapply HVOF coating, then lap it, do the same thing with the seat, and send the pair back out together. We call that a lapping kit.
Yeah, so
a lapped kit.
And that takes time, so that's not necessarily something that can be always achievable in the shutdown window. You really want to have this as a combination spare parts
mm-hmm.
kit available so that it can be sent and rebuilt sort of on a more reasonable time scale.
Yeah.
And then returned, and that's something that you can keep in the warehouse for the future.
Correct.
If you need it. Well, this is very good. I feel like every time I do one of these videos and I get the opportunity to come to someplace like this, as a process guy, I don't steal a lot of coating-related information. So we really appreciate you sharing your expertise with our audience. So thank you very much. And we really, I know I learned something. So every time we do one of these videos, I hope you learn something at home. And come back to the channel, coking.com channel. Join us for all things delayed coking, and hopefully you'll learn something too. Thank you.